All right, our first lesson is on exploring quadratic functions. So this is from chapter 6. And the quadratic function can be defined like this. Y equals ax squared plus bx plus c, where a cannot equal 0. The reason being, if a equals 0, then this would disappear, and it wouldn't be a quadratic function, it would be a linear function. So remember, quadratic means squared. So we're looking at having an x squared, okay? And there it is, ax squared plus bx plus c. So let's start with the most basic quadratic function, y equals x squared, this guy. And we'll make a table of values, and we'll graph the function and see what we end up with. So I'm going to start with -4, -3, -2, -1, 0, 1, 2, 3, 4. And whenever I substitute them into x squared, which is going to spit out the y value, remember, I always use brackets. So when I substitute and evaluate, I always use brackets. -4 squared is 16. So over here at -4, I go up to 16, and that's my first point right there. -3 squared is 9. So I'm going to plot that. That guy's right there. -2 squared, 4. -1 squared is 1. 0, 0. 0 squared, of course, just 0. And then when I put in 1, 2, 3, and 4, you can see that when I square 1, I'm going to get 1. 2 squared is 4. 3 squared is 9. 4 squared, 16. And I'm going to get all those same values again. You can see that I'm going to have the symmetry here. So 1, 2 squared is 4. 3 is up here at 9. And 4 is up, at the very top at 16. So this is the graph that we get, something like that, okay? And so what characteristics do we observe now that we've made that graph? Well, for the shape, we're going to call this an upward facing U, because it looks like a letter U that's facing upward like this, right? The domain. The domain means what are the values of x that I can put into this function. So if you think of, is there a number that I can't put in and square it? And no, there isn't, right? So x can be anything. X is an element of real numbers. So that means that this extends to the right. This line just keeps going up and to the right, and this one up and to the left for all values of x, all these. And just get rid of that ugly lines I put on there. All right, and the range are the values of y. And so the range is y is greater than 0, right? Our lowest point for y is 0. So y is greater than or equal to 0, and y is also an element of the real numbers. Okay, let's look at another one. So with this function, we've got y is 9 minus x squared. There, you can see that x squared, so I know it's a quadratic. And I'm going to try the points -3, -2, -1, 0, 1, 2, 3. And I'm going to put them into this function. So 9 minus -3 squared. What's it going to spit out for y? So this is where I'm substituting and evaluating. So this would be 9 minus 3 squared, or -3 squared. We just did that. It was 9. So 9 minus 9 is 0. Okay, and now I'm going to go 9 minus -2 squared. Well, that's 9 minus 4, which is 5. 9 minus -1 squared. 9 minus 1 is 8. 9 minus 0 squared is 9. And you can see that I'm going to get, again, that symmetry, right? That same numbers. 9 minus 3 squared, 9 minus 9 is 0. So let's plot those points. -3, 0 is right here. -2, 5. It's right there. -1, 8. Way up here at 8. And 0, 9. And then the symmetrical points. So see, where we are at this point, 4, and then over here at 0. You can see that these points, like this is 3 away from the x-axis, and so is this. And this point is 2 away, and so is this, and so on. And so when I'm saying symmetry, that's what I mean. I'm talking about that I could fold this up along this line, right? If I were to fold it along that line, if you could imagine picking this piece of grid paper up and folding it, or here, I could fold it along that line and it would match up perfectly. This would fit perfectly over top of that. And here, this would fit perfectly over top of that. So now here we see, in this second example down here, a second shape. This is a downward facing U. Domain, also all real numbers. A little bit dull for our quadratic functions there. They're always just all real numbers. The range this time, y is everything below 9. So y is less than or equal to 9. All right. So just a little exploration here of these two quadratics. So now I've got a handful of equations in here. I've got 1, 2, 3, 4, 5, 6, 7, 8. And I want to decide, is it linear or is it quadratic? Linear means the highest power that I see on the x, highest power is 1. Here, highest power is 2. Quadratic means squared. Linear means that the power on the x is 1. So if you look at these for a second and pick out which ones you think are quadratic and which ones you think are linear, and then pause it and try that, and then come back and I'll tell you the answers. So if I look at, say, this one to start off, I don't have any x squareds. This is linear. Same thing, whoops, same thing here. This is also linear, these two. What else? This guy, also linear. Even if I multiply that 2 through there, I'd get y minus 4 is 2x minus 8. It's not an x squared, it's a 2x, so this is also linear. So what's quadratic? Well, let's look at this over here for a moment. If I did FOIL on this and multiplied these out, I would get x squared minus x plus 5x minus 5, right? Y equals this. So, and then I could gather these two together, right? Do you remember that? X squared plus 4x minus 5. This is a quadratic function. And this is even a quadratic function of this form, right? When I expand it, ax squared, a is 1, plus bx, b is the 4, plus c, the c is this minus 5. So this one is a quadratic. Next, this guy, also a quadratic. Why is that? It has an x squared. Boom, quadratic. This one, imagine distributing that x. You would have x squared minus 50x. Also a quadratic. I have an x squared. And lastly, up here, x plus 5 squared. Whenever I have a binomial squared like that, what I like to do is write out that binomial twice. X plus 5 times x plus 5, x squared plus 5x plus 5x plus 25. I'm just doing FOIL, right? X squared, 5x, another 5x, 25. So this is also a quadratic. All right, leaves me with this one over here. This is a trick question. It's neither quadratic nor linear. It's actually what we call an exponential function. And in an exponential function, the x is the exponent. So this isn't even, that doesn't belong. That was a trick. Okay. So what did we see? if we look at those graphs that we made, a is the value that's with the x squared. So when it's a 1, or a positive number in this case, versus down here it was -1, a negative number, it changes the direction of opening. So is a positive? If it is, we have an upward facing U. Is a negative? Then I have a downward facing U. B, we don't really care that much about yet. B is going to help us factor. But we're not going to factor in this lesson or the next one. It'll be a little bit later, but it'll help us to factor. And C, if I look at this, this is actually written kind of backwards, this guy. It should be like y is -x squared, ax squared. There is no bx, right? So b is 0, plus 9. 9, it gives me the y-intercept. So the value of C gives the y-intercept. So there's just a little introduction into what is a quadratic function, like what does the equation look like, what does the graph look like, and A, B, and C when it's written in this form.